With the introduction of next-gen stats and the NFL Big Data Bowl, player tracking data has become an increasingly popular tool for football analytics. Currently, NFL publicly available tracking data is presented entirely in two dimensions. The x-axis between 0 and 120 represents a position between the end zones in yards, and the y-axis between 0 and 54 represents a position between the sidelines in yards. The data we get represents the position of players on the field throughout the duration of the play as dots. Here's an example of the NGS dots of a play. This play is from week 9 of the 2019 season. In this play, number 16, Tyler Lockett runs a corner route and Russell Wilson throws a perfect pass for a 2-yard touchdown. The dots are clearly informative. We know what routes were run, where the ball went, and what the blocking looked like. What we don't know is anything about the pass itself. Let's take a look at the play. We can see that Russell Wilson has to lob it over 2 underneath defenders, get it just over the outstretched arms of the Buccaneer defender, and land it perfectly in Tyler Lockett's arms before he runs out of bounds. Our dots didn't capture that. Introducing NFL3D. For the first time ever, we can track the flight path of the ball so we can comprehensively understand how quarterbacks use flight and velocity to beat defenders and complete their passes. To do this using only tracking data, we need to interpolate the z-axis. We're going to apply some kinematics equations, but before we do that, we need to make some assumptions about the environment. 1. We will assume no air resistance for this version of NFL3D. This is because we are looking for a comparative relationship between quarterbacks. 2. Since we don't have any information about where the ball is launched from in the air, we will assume a 6-foot launch point and a 6-foot receive point. 3. The only force on the ball is gravity, and the ball doesn't get tipped or batted mid-flight. The physics of a spiraling football is rather complex, and for the scope of this project, we will ignore the extra forces. Now the problem is formulated as follows. We know the xy point of the time the ball is thrown, and the xy point of the time the ball arrives. We have the movement of the ball along the 2D plane. We want to find the flight of the ball, or the z-axis. Since we assumed the only force on the ball is gravity, the flight of the ball through the air is a parabola. We can model the z position of the ball as a function of time as such. What we need to find is the vertical component of the ball's velocity vector, vz. Using that, we can use the equation to find the z position at any time. We know the time of flight, which is just a difference in time between launch and arrival, and we know from our second assumption that the displacement between the 2 points is 0. Then, our vertical velocity just becomes tg over 2. Once we have the vertical component of the velocity, we can use that vector to solve for position at any time using the following formula. We can also calculate the initial launch angle and the initial launch velocity of the ball using the following formulas as well. Now let us take a look at some results. First, here are some examples of NFL3D in action on some plays. We can see how the trajectory of the ball gives us more context. Next, we see the launch angle and velocity for different quarterbacks. We can see that the higher the launch angle, the slower the pass has to be, and vice versa. We can see some quarterbacks use higher launch angle than others, and from this chart, we see Josh Allen is clearly an exception. Now we can also see the distribution of velocities for different passers. We can see that Patrick Mahomes throws a wide range of velocities, but on average throws faster than everyone else. Looking at launch angles, we can see that Kirk Cousins throws the ball with the highest angle on average, and Drew Brees generally throws with the lowest angle on average. Finally, we can look at who threw the fastest pass. Far and away, the fastest pass was thrown by Patrick Mahomes, and Mitch Trubisky had a powerful throw as well. But on this chart, Josh Allen is only 6th. By contextualizing the throw, we can start to see how powerful NFL3D is, and there is a lot of interesting work that can be done now that the ball is in the air. We can try to understand how well players track the ball, or how well quarterbacks adapt their throws to coverages, and we have more information to analyze their decision making. With NFL3D, we can start to tackle these more complicated questions.